All right, guys. 3.6. This here is the last section of chapter 3 we're going to cover.
It's hot here.
I do.
Yeah.
Are there any questions over the homework assignments before we get started? Thank you. All right, guys. Yes. Equation. I'll need to find it here in a second because it's probably in one of these sets in the wrong spot. And I'll get it back to you. Now, guys, so the quadratic formula is the other way that we can solve any quadratic equation. Any quadratic equation in the form of ax squared plus bx plus c equals 0. We can find it using the quadratic formula. Now, there is no space for y'all to do this, because what I'm going to do here is actually show you how we get the quadratic formula. Now, the way that we get to it and the way that we get the quadratic formula is we're taking this here. This is the general form of any quadratic equation. Yes? For the values a, b, and c. If we plug in a, b, and c, and as long as a is not 0, this is a quadratic equation. So yes, I'm going to apply completing the square to this here. I'm going to complete the square with this. So I will tell you right now, there is not enough room in that little space to do what I'm about to do. So I just want you all to watch this so that you see how it works, how we get it. You're never going to have to do this again. You're never going to have to do this. So we would get x squared plus b over a plus c over a is equal to 0. Now we need to get the constant term by itself, which is our c over a. So we're going to subtract c over a from both sides, which will tell us that we have x squared plus b over a x plus blank is equal to negative c over a plus blank. So we kind of went through the first two steps. Now we need to find the value of c, which is our b over 2 squared. But in this case, b over 2 is b over a. So we have b over a squared. Well, b over a over 2 is actually b over 2a, and if we square that, we get b squared over 4a squared. So again, we're just going through these steps here. Now, at this point here, we can factor this side here, so we would have x, and then we'd have what's inside the parentheses before we square it, which is going to be plus b over 2a. Now to add like fractions, I need to multiply top and bottom so that the denominators are the same. And it's going to be 4a, because here we would get negative 4ac over 4a squared plus b squared over 4a squared. And again, once we get to the end, most likely this is going to be something that y'all are familiar with or at least seen. X plus b over 2a squared is now equal to, the denominator is going to be 4a squared. The numerator we can say is b squared minus 4ac. And our next part in solving this is going to be to square root both sides, because the square root and square would cancel, which would leave us with x plus b over 2a is equal to plus or minus. The numerator is going to be the square root of b squared minus 4ac, because we can't take the square root of that whole thing. But the denominator, we just have 4a squared. Well, the square root of 4 is 2, and the square root of a squared is a. And last but not least, we can subtract b over 2a from both sides. Which will tell us that x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. However, both denominators are 2a, yes? And the numerator is negative b plus or minus the square root of b squared minus 4ac. And this here is the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. This is the quadratic formula. This is how we get it. We don't have to do this ever again. I showed you this so that you guys have an idea of where this formula comes from. Miss Kendall does have this in her classroom. It was above the door for the longest time. Kind of pink poster stuck right above the door as you exit. This here is the quadratic formula. And again, we said this is for any quadratic. We started with any quadratic with the values of a, b, and c, yes? That means if you plug the values of a, b, and c into this, it will give you the solutions. Because we said the quadratic, or completing the square, worked every single time. And we saw that it worked with almost all the ones that we worked it with, it gave us the solutions, yes? So if I applied a method that works every time to the general equation, it means this one here will work every single time. It will give us every solution for any quadratic equation. And it's quite nice. Let a, b, and c be real numbers, and a is not 0. Then the solution for any quadratic equation is given to us by this equation here. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Now let's see how this works. So the first equation that we have is this here. X squared plus 3x is equal to 5. Whenever we use the quadratic equation, we need it equal to 0. Well, to make this equal to 0, we need to do what? We need to subtract 5 from both sides, which will tell us we have x squared plus 3x minus 5 is equal to 0. Questions on this so far? So the quadratic equation, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? Because that's the general form, yes? In our case here, in this problem, what's the value of b? 3. Because our general form is ax squared plus bx plus c. So the value of b is 3. So when we start writing this, the first thing we have is negative b. So we put negative parentheses 3 close parentheses. Stick the value of b in there. We would take the sign with it. Since it was plus 3, it's positive 3. Inside the square root, we have b 3 squared. Our b squared would be 3 squared minus 4 times a. Well, what's the value of a? I in front of x squared is. Now we need c, and the value for c is all over 2 times a, and a is. Questions on this so far? So what have we done so far? We've just plugged in the values of a, b, and c into this equation here, yes? Okay, now all we need to do is simplify. So the negative, parentheses 3, parentheses. Well, we can apply the negative to the 3, making it negative 3, plus or minus. Back here, plus or minus. Now, at this point here, I don't plug the square root in. But what I am going to plug into the calculator is all of this here without the radical. And I normally stick to the 30XS, the yellow calculators, because if this does not turn into a perfect square, so 9, 4, 9, 16, 25, 36, 49, any of those there, the graphing calculator will give me a decimal. So what I would do first is our 3 squared minus 4 times 1 times negative 5. So parentheses 3 squared minus 4 times 1 times negative 5. We get 29. So I can come back over here and plug in 29 inside the radical. And it's all over 2 times 1, which is, and this is where the yellow calculator, our 30XS, is nice. Because our next thing we could try to simplify is the square root of 29. And if we plug the square root of 29 into the calculator, we get what? Square root of 29, which tells us it doesn't simplify. That's your answer. Now we would look to see if it would reduce, because if the numbers here, in front of here, and down here, if there's a common term among all three and we can reduce the whole thing, we would reduce it. Any questions on this here? We ready for the next one? Okay. So we're starting off with 3x squared plus 4x is equal to 10. Well, to use the quadratic formula, we need it equal to 0. Exactly. We can subtract 10 from both sides, which will tell us that we have 3x squared plus 4x minus 10 is equal to 0. Which gives us this here, 3x squared plus 4x minus 10 equals 0. And we're going to solve this using the quadratic formula. Quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's go on and plug our values in. So we have negative. The b value is 4 plus or minus the square root of, so b squared is going to be 4 squared minus 4. This time a is not 1, it is 3 times c. Well, c is negative 10 all over 2 times a, or 2 times 3. And now the rest of this is just simplifying. Well, our negative 4 is going to be negative 4. The denominator, 2 times 3 is 6. And at this point here, we can plug all this into the calculator. So 4 squared minus 4 times 3 times 136. So we get the square root of 136. And again, just like before, I would plug that into the yellow calculator to see, will it reduce? So I think it does. And the yellow calculator will do that for us. We don't have to go through finding our prime, our perfect squares, and simplify. Which is quite nice. Questions on this here? Is there a common factor between -4, 2, and 6? Because there's a common factor of 2, yes? You would need to reduce that. Now, the main way we can think of that is I'm going to factor a 2 out of the numerator. And if I factor a 2 out of the numerator, we would have -2. Because if I pull a 2 out of 4, I divide 4 by 2, I get 2. If I factor a 2 out of 2, we get 1, so we're just left with the square root of 32. And this is all over 6, yes? We will, because that's what I was getting to. Because 2 over 6, this would reduce to 1, and the 6 would reduce to 3, making the denominator 3, leaving us with our -2 plus or minus the square root of 32. So if we can reduce it that way, we can. I'm not going to make you split up the fraction into 2 fractions if one will reduce but the other won't. We can just leave it as this here. So if the top 2 and the bottom all have a common factor that we can pull out, the same common factor, then we're going to. Questions on this here? We ready for the next one? Let's look at the next one. X squared minus 6x plus 4. Is this already equal to 0? So we're saying x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. Because that's where we're starting with, and we're going to plug our values for a, b, and c in. So we'll have -6 plus or minus the square root of b squared -6 squared minus 4. Now our a value this time is 1, and c this time is 4 over 2 times 1. And again, at this point, we need to simplify. Well, -6 is going to be +6. Plus or minus. And the denominator 2 times 1 is 2. So the only other thing we need to simplify at this point is our -6 squared minus 4 times 1 times 4. So on the calculator, we could say -6 squared minus 4 times 1 times 4, which gives us 20. So the number inside the square root is 20. Questions on this here? Six, 2. Yes. Now we do need to see if the square root of 20 would reduce, and we can type that into the yellow calculator, which will tell us that it is 2 square root of 5, I believe. Yes? Any questions on this so far? Any questions on any of this so far? Will the 6, 2 squared, and 5, and 2, will all of these divide by 2? Will 6 go into 2? Does 6 go in, or so 2 goes into 6, yes? Does 2 go into 2? Then 2 will go into 2, yes? So we could do the same thing we did before and factor 2 out, which would leave us with 3 plus or minus the square root of 5 over 2, yes? 2 divided by 2 is 1. Telling us that this is 3 plus or minus the square root of 5. Or we could have just divided each of those 3 spots by 2 and see what we got. Either one works. Questions on any of this here? Are you ready for the next part? Or the next problem? Yes. Do we feel comfortable with these here? No? Yes? Let's do one more, and then we'll move on to the next piece. So here, again, we need this equal to 0. So we would add 7x to both sides. And again, we plug in the value of b to start off with, because we have negative b, so it'd be negative 7. Plus or minus the square root of, so b squared would be 7 squared, minus 4 times a, and a in this case is 2 times c, which is 4. All over 2a, or 2 times 2. And once we get the numbers, or the values of a, b, and c plugged into our formula, we just need to simplify. So our first spot is negative, parentheses 7, close parentheses, which is just going to be negative 7. The denominator, 2 times 2 is 4. And the next part is to simplify what's inside the radical. So our 7 squared minus 4 times 2 times 4. Which gives us 17. Now we can plug the square root of 17 into the yellow calculator to see, does it reduce? Is there a term that we can pull out? Which there is not. So since there's only a 1 in front of the square root, this won't simplify. Also, 7 and 4 don't have a common factor to reduce. So that there's our answer. Any questions on any of this here? Yes, sir. Yes. Any questions on any of these so far? Do we need to see another example of one of these? All right, let's look at this one here. This one here is a little bit different, mainly because it says that it has one real solution. Yeah, but that's what it says in an example. Solve an equation with one real solution. So what we need to do for this here, to start off with, is we need this quadratic equation equal to 0. So what we can do for this is to subtract 12x from both sides. And if we subtract 12x from both sides, we get 25x squared minus 20x is equal to negative 4. And at this point here, we can add 4 to both sides. And if we add 4 to both sides, we get that 25x squared minus 20x plus 4 is equal to 0. So negative b plus or minus the square root of b squared minus 4ac all over 2a. And in our case here, our value of b is negative 20. Thank you. Inside the square root, we have b squared, so that would be negative 20 squared, minus 4 times a, our value of a is 25, and the value of c is 4, all over 2a, or 2 times 25. Any questions on this here so far? Any question or anything we've done thus far? Okay, now we do need to simplify. Well, negative 20 is just 20. The denominator, 2 times 25 is 50, plus or minus. Now our next part is going to be to plug in everything inside the square root. So we would have parentheses negative 20 squared minus 4 times 25 times 4. So negative 20 squared minus 4 times 5 times 4, yes? I thought something seemed a little off. It's 25. 25 times 4, which is 0. So what goes inside the square root is 0. Well, what is the square root of 0? 0, yes? What is 20 plus 0? What's 20 minus 0? So really, all this is saying that x is equal to 20 over 50, yes? And that's it. Because whenever the square root, what's inside the square root is 0, we get one unique answer. We still have 2. They're both 2/5, but we only have one that's unique. Questions on any of this here? Let's look at this next one here. Now again, when we solve these, we need these equal to 0. So the first thing we can do is subtract 13 from both sides, which will tell us that we have negative x squared plus 4x minus 13 is equal to 0. Now when we were factoring, we wanted the x squared, the number in front of x squared, to be positive, but with the quadratic formula, it doesn't matter. We just need to plug these values in. We have negative b, well, our b value is 4. Plus or minus the square root of b squared, so that'd be 4 squared minus 4. A is negative 1 and c is negative 13 over 2 times a, 2 times negative 1. And again, just like before, we will simplify. So our first one is going to be negative 4, plus or minus. The denominator is going to be negative 2. And again, at this point here, we need to simplify what's inside the radical. So it's going to be our 4 squared minus 4 times negative 1 times 13. No. Negative 13. And we can type this all in and hit enter. And in this case, we get negative 36. And this is part of the reason I don't type the whole thing into the yellow calculators, the 30xs, because it would give us an error, because the yellow calculators cannot take the square root of a negative number. But we know at this point here, x is equal to, so negative 4 plus or minus, and we have negative 2. With negative 36, the negative is going to come out as I, yes? Which leaves us with what? The square root of 36, which is 6. So the square root of negative 36 is 6i. Questions on this here? Will all three terms, do all three terms have a common factor? Yes. Negative 2, don't they? We could divide everything by negative 2. We can factor it out of all this here. So we wouldn't mess with, because I is still going to be there. Yeah. Or a square root of negative 1. So what we could do is we could pull out a negative 2 if we wanted to. It's going to make this easier. Mainly I pull out the negative because we don't want the denominator to be negative. That's one of the big issues. We don't want the denominator negative. Now if I factor a negative 2 out of negative 4, we're left with positive 2, yes? Now with the 6, if I factor a 2 out, I get 3, we'll still have I, yes? Now what was in front of the 6, the plus or minus, yes? So if I pull a negative out, the plus becomes minus, yes? But what happens to the minus? If I pull a negative out of the plus and minus, it becomes plus and minus. It doesn't change it. Well, it does. It just flips it, but we end up with the same thing. Over negative 2. These two will cancel, leaving us with 2 plus or minus 3i. Questions on this here? We good with this here? Yes? Okay. This is the last part of the note sheet that we have. Yep. This is it. This is the last thing we're looking at. Is the discriminant. When we talk about discriminant, I believe this does come up on the ACT, they're talking about the b squared minus 4ac. B squared minus 4ac. Now if b squared minus 4ac is greater than 0, we have two real solutions, and that's part of the piece I would write down. B squared minus 4ac, if it's greater than 0, we have two real solutions. Now if b squared minus 4ac is equal to 0, we have one real unique solution. And if b squared minus 4ac is less than 0, we have two complex solutions. And I think they call it imaginary solutions. Either one, that's the same terminology. So the b squared minus 4ac really gives us an idea of what kind of solutions we should expect from the quadratic equation. So if we look at these three here, find the discriminant of the quadratic equation and describe the number and type of solutions of the equation. So if we look at the first one, we'll need both of these equal to 0. The discriminant is our b squared minus 4ac. Well, the value of b in this case is negative 6 squared minus 4. A is 1 and c is positive 10, yes? Now we can type this into the calculator to find out what this is. So negative 6 squared minus 4 times 1 times 10, yes? Which tells us this is negative 4. So how many solutions do we have? 2 complex, because the value of b squared minus 4ac, is it greater than 0, equal to 0, or less than 0? Less than 0, so it would be imaginary or complex. You can use either one. They're going to mean the same thing. So we'll have 2 complex solutions or 2 imaginary solutions. And that would be it. I mean, we could go back and solve it by plugging negative 4 in and using the quadratic formula to find it from there, but we would have 2 complex solutions. Questions on this here? Let's look at the next one, b squared minus 4ac. And again, our b squared is still 6, minus 4, a is 1, but this time c is 9. So we're doing negative 6 squared minus 4 times 1 times 9. So here we have negative 6 squared minus 4 times 1, but this time it's times 9, which gives us 0. One real solution. One real solution. Well, it's really one unique real solution, because we still have 2, it's just that the solutions will be the same number. Because it's like the one we had before, x equals 2/5. Well, x is equal to 2/5 and x is equal to 2/5. They're the same number. We have one real solution, but it's just we didn't have 2 unique solutions, like negative 1/5 and 2/5. We don't have 2 of them. And the last one we have is b squared minus 4ac. Well, we still have, so negative 6 squared minus 4 times 1. But this time we're multiplying it by 8 for c. So negative 6 squared minus 4 times 1 times 8 is positive 4. So since this value is greater than 0, we have how many solutions? 2. We say 2 real solutions because the value of b squared minus 4ac is greater than 0. Questions on any of this here? Questions on any of this here so far? And really, that's it. So we good on finding the discriminant and the number and type of solutions? Yeah, we're not sure. And that is it. That is it for this here. So the assignment on that worksheet on the back, (6 through 16) even. So you're doing those to use the quadratic formula to solve each one of those. If you want to use your graphing calculator, use a graphing calculator to check your solutions, you can. 21 through 24, find the discriminant of the quadratic. So you want to find out what b squared minus 4ac is, and the number and type of solutions. You don't have to solve 21 through 24, but you do need to find the discriminant and saying it's either 2 real solutions, 1 real solution, or 2 complex solutions.